హలో స్టూడెంట్స్, ముందుగా మీ అందరికీ శ్రీ క్రోధినామ సంవత్సర ఉగాది మరియు రంజాన్ శుభాకాంక్షలు. ఈరోజు మనము ఏపీ న్యూ 10th క్లాస్ మ్యాథమెటిక్స్ సిలబస్ ప్రకారము సెకండ్ చాప్టర్ పాలినామియల్స్ గురించి నేర్చుకుందాము. దాంట్లో ఎక్సర్సైజ్ 1 ని సాల్వ్ చేద్దాం. సో పాలినామియల్స్ పాలి అంటే గ్రీక్ వర్డ్ ప్రకారము మెనీ, నామియల్ అంటే టర్మ్స్ అని అర్థం. సో పాలినామియల్స్ అంటే మెనీ టర్మ్స్. పాలినామియల్స్ అంటే సింపుల్ గా మెనీ టర్మ్స్. కాకపోతే మనం ఒక డెఫినేషన్ అనేది రాసుకుందాం. సో ఇక్కడ ఏ పాలినామియల్ is composed of constant variables and exponents combined by additions, subtractions, multiplications, and divisions. సో ఇక్కడ డివిజన్స్ అనగానే జనరల్ గా మనము 8th 9th లో కూడా వస్తాయి కాబట్టి కొంచెం చిన్న డౌట్ వస్తుంది. బట్ variables not involved in divisions. సో ఇది నెక్స్ట్ స్టాండర్డ్ ఫార్మ్ ఆఫ్ పాలినామియల్. సో హై స్కూల్ లెవెల్కి పాలినామియల్ ఇన్ ఎక్స్. So P of x equal to an x power n plus an minus 1 x power n minus 1 plus an minus 2 x power n minus 2 and so on up to a 0, where an minus 1, an minus 2 and so on up to an a 0 belong to Set of real numbers are, and these are the numerical coefficients of x power n, x power n minus 1, x power n minus 2, and so on up to x power 0 respectively, where a suffix 0 is called as a constant. X power 0 can be written for the constant term a suffix 0, and here, as per the definition of standard form of polynomial, n belong to set of whole numbers. Now, types of polynomials, we can tell the types in two ways. So, depending upon the number of terms of the polynomial, if number of terms is 1, we call it as monomial, and if the number of terms is 2 terms, we call it as binomial. And examples are the, if number of terms are 3, we call it as trinomial. More than 3 terms, we call it as multinomial. So, multinomial has more than 3 terms. Example, 6p minus 7q plus 3x minus 1, 1 plus 2t plus 3t square plus 4t cube plus 5t power 5, like this. So, we can write multinomials. Now, types of polynomials depending upon the degree of the polynomial. So, degree is 1. Degree is 0, then we call it as a constant polynomial. 6 comma minus 35, and here 4 by 3 we can understand that as per the definition, numerical coefficients must be real numbers. They may be fractions also. Even I can write root 5, etc. Next, for 6, we can write 6 equal to 6 into x power 0. So that's why degree of a constant polynomial is 0, and it depends upon the exponential formula we have learnt. Anything power 0 equal to 1, where a not equal to 0 and a belong to R. So here exponent of x is 0, so the degree of constant polynomial is 0. Next, if degree is 1, we call it as a linear polynomial. So the examples are 2x, 3p minus 4, if degree is 2, we call it as a quadratic polynomial. Polynomial polynomial. So examples 3p square, 2x square plus x minus 2, 6x, 6yz, where y power 1, z power 1 means 1 plus 1 equal to 2. By this also we can tell the degree of the given polynomial. So if the degree is 3, we call it as a cubic polynomial. Examples are 8p cube, 7x square y, 3x cube minus 2x square plus x minus 9. By observing all the examples, we can come to a conclusion that degree of a polynomial is independent of the number of terms in it. Now let us go to the standard forms. For 0 polynomial, p belong to R, p is a constant. For a linear polynomial with degree 1 ax plus b where a not equal to 0, ab belong to R. Now for quadratic polynomial with degree 2 ax square plus bx plus c where a not equal to 0, a comma b comma c belong to R. Next, cubic polynomial with degree 3 ax cube plus bx square plus ex plus d, a not equal to 0, a comma b comma c comma d belong to R. R means set of real numbers. Zeros of a polynomial. If p of x is a polynomial in x, then k belong to R, for which p of k equal to 0, then k is called as 0 of the given polynomial p of x. Now let us go to the geometrical definition. If p of x is a polynomial represented as a graph, the x coordinates of the points at which graph of p of x intersects the x-axis are called as zeros of given p of x. Graph of linear polynomial y equal to ax plus b where a not equal to 0. So this shows a line, that means a straight line. If it intersects x-axis at minus b by a comma 0, then x coordinate minus b by a is 0 of that linear polynomial. So intersecting point is minus b by a comma 0. graph of y equal to ax square plus bx plus c a not equal to 0, you remember it is standard form, so it is a parabola. So if parabola is open upwards, then a greater than 0. If parabola is open downwards, then a less than 0. Now exercise 2.1. First question is the graph of y equal to p of x are given in figure 2.10 below. For some polynomial p of x, find the number of zeros of p of x in each case. First question, number of zeros of graph is 0 as the graph is not intersecting the x-axis at any point. Second question, number of zeros is 1 as the graph is intersecting the x-axis at one point. Third question, the number of zeros is 3 as the graph is intersecting x-axis at 3 points. So the number of zeros is 3 as the graph is intersecting at the graph is intersecting x-axis at 3 points. Number of zeros is 2 as the graph is intersecting x-axis at 2 points. So here intersecting x-axis is a common one. Number of zeros is 4 as the graph is intersecting x-axis at 4 different points. 4 different places also we can tell. Now sixth one, number of zeros of given graph is 3. Number of zeros is 3 as the graph touches the x-axis at 3 different points. Few more graphs like this. Here we have parabola open downwards. A number of zeros is 1. Number of zeros is 0 as the graph the parabola not intersecting the x-axis. Number of zeros is 1 as the graph or line intersecting x-axis at 1 point. Number of zeros is of the graph is 1 as the line intersecting x-axis once. Number of zeros of the graph is 1 as the jigsaw line or the curve or the graph is intersecting x-axis only once. Number of zeros of the graph is 1 as the graph or parabola intersecting x-axis at 1 point.